Hi, it's Dave Dugal, founder and CEO of EnterpriseWeb. As you might recall, back in May, we premiered an industry-first demo of Telco-grade Generative AI for intent-based orchestration. That was at the Big 5G event in Austin, Texas. The presentation was very well received. We did a live demo, and since then, we've been in discussions with telecoms around the world and doing some POCs so they can explore how they can incorporate these technologies into their own operations. Of course, we haven't been sitting on our laurels. We've been extending the use of GenAI and AI in general across our platform. And today, I'm particularly pleased to announce that we just won an award from Light Reading, a Leading Lights Award for the best AI ML use case based on this very work. So today, we're going to bring you up to date on our capabilities, our architecture, and with a new demo. So let's move ahead. Generative AI presents a transformative interface for human-computer interaction. The informal conversational style has captivated the imagination of both the public and industry. However, in the last 4 or so months, since the premiere of our demo, there's growing recognition of the accuracy, intellectual property, cost, and sustainability concerns related to generative AI. All of these need to be addressed before organizations can responsibly leverage generative AI within their operations. For our part, Enterprise Web provides an AI-enabled no-code platform. We make it easy to design, deploy, and manage intelligent business and infrastructure applications. To do that, we use a graph-based technology. The graph provides the necessary domain knowledge, that's the context, constraints, and capabilities sort of missing from generative AI or safe enterprise-grade generative AI automation. In our demo today, we're going to show you how generative AI and intent-based orchestration combine to provide a transformative customer experience for telco. It's going to speed and ease customer service ordering, automate and accelerate service delivery, and continuously observe and optimize services for the telco operations as well as their enterprise customers. We have a simple story here for if you are a telco business customer that I think anyone can relate to. As an enterprise customer, I want to easily order a secure low latency network service for my application. I want to do it with minimal time and effort. I want for my network service to be stood up on demand. I don't want to wait. I also want to be confident that my SLAs are going to be met on an ongoing basis. Now for our demo, we're going to present a private MEC scenario with a secure 5G gateway use case. We're going to show how a developer is able to design, deploy, and manage a complex network service, something that might take a team of engineers weeks to do, and they're going to do it in a few minutes, expressing their intent via an informal natural language conversation with our platform. It's a real service, and we're going to deploy it live in front of you, and you can see we're working with market-leading companies on this and other use cases. That's enough for slides for now. Let me pass it to my colleague Bill for the demo.
Thanks for the handoff, Dave. Now I'm going to log into EnterpriseWeb and I'm going to compose, deploy, and manage a new network service using GenAI. Show me a list of service templates.
Working on it.
Show me the graph of a 5G gateway.
Working on it.
Add a firewall.
Working on it.
Add a web conferencing server.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose network service template.
Please specify which firewall from the catalog you want to use.
Use the Fortinet firewall.
To do this, I will create a new network service template named Secure 5G Gateway. Add an instance of EtherStack for RAN and Core. Add an instance of Fortinet FortiGate to act as a firewall SD-WAN provider. Add an instance of Fortinet FortiWeb to act as an application firewall. Add EnterpriseWeb SMO for RAN management and add EnterpriseWeb NSSMF for core management. Would you like me to proceed?
Yes.
Okay, working on it. Service template created.
Okay, base service is good, but I want this to have optimizations throughout its life cycle, so we'll add a SON to do that. Execute command add a SON.
To do this I will add self-organizing network to network service template, add KX instance for self-organizing network to network service template, and then I will prompt you to specify the intent of the self-organizing network. Would you like me to proceed?
Yes.
Okay, working on it. Adding self-organizing network. Would you like the self-organizing network to optimize for low latency, energy efficiency, or low resource consumption?
Optimize for low latency.
To do this I will set intent to optimize latency and configure all components so that the self-organizing network will minimize latency of the service. Would you like me to proceed?
Yes.
Okay, working on it. Optimizing network service for low latency.
Okay, now I'd like to add a northbound interface so that I can order this service from an OSS or similar system. I'll use GenAI to help me do that. Show me all interfaces. Okay, so here you can see that the system has already automatically generated a set of standards-based interfaces that are relevant to this service. I can also add optional additional interfaces if I want to customize this list. Let's go ahead and do that using GenAI. Execute command recommend a new interface.
I found these interfaces in the catalog that seem the most relevant based on the composition of this service. You can ask me to add one of those.
Okay, this one looks pretty good. It's for ordering. We can verify it by taking a look at things like the data model, and since it looks like what I want, I'll go ahead and add that to the system. Execute command add TMF 641 interface. Okay, and that's been bound to the service here down at the bottom. We can take a look. The payload looks good, so we're pretty happy. Now I'm going to proceed to the deployment workflow and see if I want to make any changes there. What can I do here?
Available operations are shown on the screen.
Show me the workflow. Okay, so what I see here is actually a state chart that models an event-driven data flow process, in this case representing the deployment of this service. Unlike static workflows, these are a bunch of loosely coupled tasks that are connected by policies. At runtime, the path of each process instance is going to unfold step by step based on conditions. And in addition, each one of these tasks is going to be optimized for the interaction context. We can actually take a look at how that would play out in the system using a quick little simulation. You can see most of the tasks here kind of unfold one by one. Then we run into a part where we have some parallel actions that go on for instantiating and configuring the service, and eventually that plays out to registering in a catalog. We can even visualize this as a sort of standard looking flowchart. But opposed to standard approaches, this supports smart, dynamic, highly optimized processes, and they're very easy to design and manage. In this kind of a case, we're actually even going to add just an optional or additional task here down at the bottom for instantiating and updating an inventory. Execute command add a task. And again, I could manually configure this, or I could just ask the system to help me do that quickly. Execute command, configure this task to update my inventory.
I detected the following registered inventory source. Sample inventory. Would you like me to create an advanced configuration to update that system? Applying default mappings and policies?
Yes.
Okay, working on it.
Okay, so that looks good. I'm going to just place this in my workflow and then confirm that everything looks good. Render workflow.
Flowchart rendered.
Okay, so I can see it down here at the bottom. My update inventory task is in place. So I'm going to proceed to deployment, but just one note, I'm going to deploy without the healing policies in place so that you can see the impact of the SON. Execute command, deploy an instance without day 2 operations active.
To do this I will deploy via LCM operation. Instantiate and deploy with day 2 policies deactivated. Warning, not advised. Would you like me to proceed?
Yes.
Okay, working on it. Network service instance is being deployed.
Okay, and if I pop into OpenShift, I can see that it's actually deploying the pods here as we speak. So it's already being stood up. And if we go into the dashboard provided by one of our partners, KX, who's actually providing the analytics for the SON, we can see that at present, as we sort of expect, all of the resources that are involved are behaving well. They're all underneath this threshold here, which is where the SON will start throwing events to EnterpriseWeb so that it can do things like heal and optimize and so on. So right now, everything is looking good for our service. And if we pop back into EnterpriseWeb, we can even confirm that. We can see that it's active, and we can look at the deployment trace here. We can see that that event was triggered by our GenAI when we asked it to deploy, and we can see about 100 high-level operations that were done, things like everything from querying the nets and creating subnets and so on, down to configuring and deploying the CNFs, and eventually, even in part of this process, we'll see that it updated our inventory. So our service has now been deployed and is ready to be used. We'll do that quickly for the demonstrations. Just a second here. So just placing this quick little call. So here, just passing video over the service, so everything looks good here. Hello, everyone. Now what I'm going to do is I'm going to, where is it here? Just a second. I'm going to simulate 50 gigs of traffic with attacks using one of our partners, Keysight in this case. So we're going to go ahead and do that and see what it does to our service.
Attention. Poor latency was detected in the deployed network service. Would you like to activate day 2 healing policies to correct the problem?
So you can see that they didn't have enough bandwidth to continue the video. And if we pop back into KX, we'll see all the signals here now are above that threshold. So it's actually throwing events to EnterpriseWeb that in this kind of a case, the GenAI actually picked up on. So we'll go ahead and actually take their suggestion and activate those policies. So in just a second here, let's go back into the system and do that. Yes.
Okay, working on it. Day 2
Okay,
healing
video's
policies
back. So hi,
activated.
You can see inside the system now that events are starting to stream in, both for the sort of optimization itself and then any of the healing. And then if we go back into KX, we'll actually be able to see really quickly here that the signals have now dropped below that threshold. So everything has been corrected with the service. So that concludes the demo. Thank you very much. I hope you enjoyed it. And back to you, Dave.
Awesome. Thanks, Bill. So let's quickly review what Bill presented. So in telco terms, we just went through day 0, which is essentially the design, network service design stage. Day 1, which is the automated deployment, which you also saw. And day 2 and beyond, which is sort of the ongoing operations and management of that running network service. So on day 0, Bill was able to speak to the system and request a secure 5G gateway, which the system proposed. The system exposed some configuration capabilities, and Bill was able to optimize it for low latency. He deployed the service, and the system generated a deployment workflow and then executed that deployment workflow with no human intervention. And then on an ongoing basis, closed loop automated management for the life of the service. Bill deployed a self-organizing network alongside the service. That SON provided observability over the service, and when it saw spikes in traffic or attacks, it reports that to EnterpriseWeb, and EnterpriseWeb generates a mitigation plan, which maintains the optimization of the service for its life. Now let's take a quick look at the solution architecture. And here you can see the management and control plane being depicted, as well as the cloud, and the role of generative AI with Jarvis, which is an open source natural language project, as well as OpenAI's foundational model, ChatGPT-4, which are both being used in today's demo. Let's go look at some other use cases that we support with generative AI. We do an IoT gateway, secure video conferencing, home streaming cache gateway, all supported by generative AI. Now, of course, we've been able to support these for years through our API and UI, but the difference here is this, with this generative AI interface, is that it's abstracting away the technical complexity so that someone can informally design a service and have it deployed and managed without having to worry about any of the technical details. Now I'd like to explore the differences between conventional LLM-oriented generative AI and what we do at EnterpriseWeb, which is domain-oriented generative AI. Let's start with the definition. It's mine, but I believe it generally holds. An LLM-oriented architecture is a conventional approach to generative AI where the LLM is the primary component that handles the processing of prompts and provides responses. This is essentially what people are doing all around the world today. But as we've discussed, there are limitations to this approach. LLMs are purely statistical analysis with probabilistic responses based on tremendous data sets. Right? Large language models, hardly captures the vast data sets that are being used by LLMs. Processing is compute intensive. It's what we call computer science brute force. The responses are still only approximate. They're not at exact matches. They never become deterministic. LLMs support creative, subjective, or draft level activities, which require human oversight. The LLM responses are subject to hallucinations, which are subtly or overtly wrong in unanticipated ways. There's no rhyme or reason to the way the LLM works. There's no logical traces to explain its behavior. And that's why LLM-oriented architectures are being extended to improve LLM responses. So now, for those of you familiar, there's a variety of methods being explored. Chain of thoughts, tree of thoughts, graph of thoughts, factual grounding, vector databases, graph knowledge databases, retrieval augmented generation, right? There's just a variety of methods and approaches to try to improve results from generative AI. But those are all still LLM oriented, right? The LLM is still this primary component that's handling the processing of the prompts and provides the responses. Everything is either just training or tuning the LLM, or it's supplementing the LLM with some additional, supplementing the prompts with some additional context. But the LLM is still the primary component processing the prompts and the responses. This is distinct from what we're doing in EnterpriseWeb. In EnterpriseWeb, we're implementing a domain-oriented architecture. And again, let me start with the definition. Domain-oriented architecture is an alternative approach to generative AI where a customer-controlled systems domain is the primary component that handles the processing of prompts and provides responses. And the LLM simply supports an NLP interface, right? So in this model, a domain-oriented architecture mitigates accuracy, IP, cost, and sustainability concerns by reversing the flow of control. The LLM serves only as an interface. As with UIs and APIs, processing is handled by the backend. Requests are translated by the system that provides domain context, constraints, and capabilities. We talked about that early in the presentation. The approach supports deterministic and transactional behavior, enabling new enterprise-grade generative AI use cases. So this difference between being LLM-oriented and domain-oriented is a big distinction. LLM-oriented is, the LLM is the primary processing component. Here, the LLM is just another interface, just like an API, just like a UI, and it's feeding back-end systems which do the processing, that add the context, that add the controls, the constraints, the policies, the domain knowledge to ground the translation of the request, of the intent, and translate that into a contextualized response. Note that I'm not using the term prompts anymore. It's request. It's requests to a backend system. They're not just prompts, they're queries and commands to that backend system. On the other side, you're getting real-time contextual and deterministic responses and actions. So this is a very big distinction from the LLM-oriented architecture. For this solution that we presented, we're working with our partner KX, as well as Jarvis, which is an open source natural language programming project, and OpenAI's ChatGPT 4 foundational model. So essentially, we're working with the state-of-the-art natural language interface. KX represents state-of-the-art vector native time series database. And EnterpriseWeb, which is really a state-of-the-art automation platform, right? That's using knowledge graphs and logic programming to contextualize every interaction on demand. Now let's explore some of the benefits. So in an LLM-oriented architecture, you're getting a curated private domain that's always up to date with model activity and state changes. That's a big difference from an LLM-oriented architecture, where you have to invest in that LLM, training and tuning the LLM. So as a result, a domain-oriented architecture is going to have faster time to value, reduced upfront and maintenance cost, and it's going to have no LLM lock-in. In addition, because we're intentionally minimizing the number of prompts and tokens, we're lowering the operational cost of generative AI. A lot of people are just starting to realize how expensive an LLM-oriented architecture actually is. Moreover, EnterpriseWeb and KX run on customer x86 environments or tenants. So it's the customer-controlled environment on technology they're familiar with, no GPUs required. Architecturally, KX is acting as an intermediary. Not only is it translating from sort of the vector language of the neural networks to the symbolic language that EnterpriseWeb speaks, it's actually providing an intermediary, isolating EnterpriseWeb from direct contact from generative AI to mitigate the security and IP concerns. So in total, this domain-oriented architecture is actually mitigating the accuracy, IP concerns, cost, and sustainability issues related to LLM-oriented architecture and generative AI as it's conventionally practiced. And the whole point is to provide enterprises with a practical solution that expands use cases, enterprise-grade automation. So from a computer science perspective, this is pretty exciting because we're actually bridging neural networks, which is what LLMs are, and symbolic AI. You can call that the sort of new AI represented by generative AI and the old AI represented by symbolic AI, the logic-based programming, bring them together in something that computer scientists call neurosymbolic AI. And you can almost imagine that being like the left side and your right side of your brain. You really want them both working together. One side is creative, the other side is logical and rational. And you really want those two to work together for optimal effect. So in closing, EnterpriseWeb is the ultimate backend for generative AI. We're providing a graph knowledge base that provides domain context, constraints, and capabilities for intelligent automation. The technology is agent-based platform with a serverless engine for lean, scalable, event-driven task automation. Our agents are dynamically dispatched, configured, and coordinated to execute tasks based on interaction context. Our agents handle reliable messaging, transaction guarantees, and state management in the same data flow pipelines. It's all abstracted away from the developer. That's what supports the generative AI interface. It what allows a very high-level expression of intent to be translated into low-level industrial-grade automation. So thank you, everybody, for your time. Really appreciate your interest. We look forward to speaking with you.